let's import some data into Stata. To make things easy and faster, I will use a do file that I already have with all the commands that I'm gonna show you in this session. So I already open it here. So this is basically the first steps, the first lines of code that we have. Now we're gonna do import data into Stata. So as I said in the introduction, we have data from three different sources. So we're gonna import the COVID data first, cases and deaths, from this website. So at the moment that you're watching this video, it might be a good idea to download the data, the current data, and then to see how the trends keep changing or have changed since I use these files. The COVID data from this data set comes in what is called CSV format. This is comma separated values. This is an ASCII file that any software can open. For the most part, or more, we open this file in Excel. If you want to explore it first, make sure that it's in the correct format, as per what I mentioned in the introduction. There is also tab separated values, which is also an ASCII format. But if you want to see this file not in Stata but in Excel, you just open it from Excel. If you have a Mac, I will suggest to not double-click on the file, but actually open Excel, and then from Excel, file open, and look for the comma separated values format. So the command to import CSV files is import delimited, and then you type exactly the name, how the file is named, and then clear. Once you get comfortable with this data, you can actually use the command line. For those who are just beginning with Stata, and even those who are more advanced, probably it makes sense to use the menu. So if you go to the file and import, the file menu and then import, you can see all the types of files that you can import in Stata. So you can import Excel, the limited files, ASCII files, CSVs. You can also import data from SPSS. Any file that has extension SAV, you can actually import that. SAS data, SAS 7B dat, you can actually import those directly into Stata. And there is some other formats. So if you click on the tab delimited, which is the one that we need, a new window pops up, and then click on the yellow envelope to the right. And then you can see the two files. Let's bring the confirm file first, which is the cases file. And then it's going to give you a little preview of the file. So the first row has the variable names, and then the data. I mean, everything looks fine so far. So then you press OK, and then the data opens. If you look at the window on the upper right corner, where it says the variables window, now we can see some variables in there. So you have the variable name in the first column, where it says name, and the corresponding label. If you click on one of those, you see the variables window gives you some information about it, about the data, the variable, and the data window gives you some general information of the data. We have 964 variables, 286 observations, and the size of the file. Now, if you notice, everything you run from using the Windows, the menu, the Stata gives you the code. So as soon as you get the code for something that you need to run, just right-click, copy, and let's paste it into the do file. Make sure you have a comment there. So import delimited, cword, in this case, because he adds the path to the file. And then the clear is not here because I I just like to put it just sometimes when you have to rerun this and you already have data open in Stata, Stata asks you whether you should close or save the existing file. So when you type clear, the option clear, it closes the previous file and it replaces with this one. So this code is pretty much the same. So the only difference is that I remove the path because the path is already set in the working directory. So to make it a little bit more clean and more lean, and then you just type clear, and then that's the code. So next time I open the do file, and if I need to run this again, let's say I lost the data or something bad happens, you can always re-import by running this line. Once you import and save it as Stata, you don't have to import it again. Now the next step is once you put the data into Stata, let's check it out, and then you can type browse here, you can run this, and then a third window open, which is the browser. It looks pretty much like Excel, so you can see the data. So at the top you can see the variable names, and then you can see the values after that. So you can move it all the way down, and towards the end there is more variables. And if you notice, there is also, these are all color coded. So anything in red, the Stata assumes is a string. Anything in black is numbers. So we can perform a statistical analysis with numbers. We cannot do much with the strings, other than just frequencies. Now, you notice these two variables here they are numbers, but they are in red. The problem with this is that somewhere in the cells, and we can see the culprits right here, the cells or some of the cases are mixed with the strings. When Stata finds one character or one non-numeric character in the variable, it assumes it's a string automatically. So it converts, instead of reading these values as numbers, it converts them to string values. So I'm going to show you how to deal with this. Another thing that you notice here is column B4 doesn't have a name. Column B4 is supposed to be long, as in the coordinates, longitude and latitude. And Stata, there are one reason for this is that because sometimes Stata don't like command lines or variable names that have the command lines, that recognizable command lines. So long is a way to format some values. So because Stata doesn't recognize that long, when it imports everything in lowercase, so it replaces with a column name. And then if you notice B5, B6, B7, all the way down to 957, if you notice, it replaces also the names of the dates with the column positions, so the column numbers. And this is because Stata doesn't like numbers as columns names. So in the original CSV file, if you open the CSV file in Excel, the column names are dates. And for all purposes, Stata assumes it's a number, and the dates are actually numbers. So what it does is it changes, it put the names as labels and rename the variables with the column names. So these are the first steps that you have to deal with. Sometimes, especially when you collect data from different sources and the data is not in any proprietary format, you have to do some additional cleaning. And this is the cleaning that we have to do now. So let's say, for example, you want to put this long variable back into the original name. So that is rename. So the command for Stata, the Stata commands are kind of like make sense. They are commonsensical. So basically, there is a command called rename. The format is very simple. So rename all name, which is the B4 in this case, so column 4, and the new name, or the name that you want. We cannot use long because it's part of a Stata system. So let's use longitude. So again, select the line and click on the last icon, and that runs the line. And then you have Now, instead of before, you have longitude. So that actually renames the variable. Now, let's another way to see the data, if you don't want to run browse from there, in the icons section here, below, right below the menu, you can edit the data or you can browse it. So you click on the browse icon, it opens the browser window again. So now let's see, these are supposed to be numbers. So we're not going to use these variables, but I'm going to show you in case you encounter this issue in your own data. What makes these numeric variables string variables or text variables are these variables here that we see, hashtag geolat and hashtag geolong. So we need to convert, we want this 33 to be a number, not a text, or the same as the other numbers. So Stata has a way to do that. And the command is called dstring. If you want to know more about this command, just type help dstring. Also for rename, you want to know more about how rename works, just go and type help. Go ahead and type help rename, and that will give you more information. Also, it gives you other options that you might need in your work. So for now, let's start with dstring. In dstring, you can actually list all the variables that you want to convert from text to numeric. In this case, these two, lat and longitude. And then you're going to replace, because we don't need the variables in a string, we need the variables, we want them in numbers. And then because we have two pieces of strings here, Stata is not going to do anything as long as we have this, the two here. We can ask Stata to ignore those two pieces of information or additional data that we don't need. If you, for example, have a comma or you have a letter or some string character, you put it in here in quotes, and then the Stata is going to ignore it. So again, once we finish set up the line, so just select and run, and then you run. It says the variable was placed as double, and let's go back to the browse, and now this lat and longitude is in black. These are numbers now. And the text that was giving us the headache, it converted to numeric. One thing that you need to notice here is that missing values in numeric format in Stata are signaled as dots. You see these dots. If you see a dot there, is that there is a missing value. In the case of strings, missing values are empty or blanks. So we need to keep that in mind for later on in the process. Another thing that we need to do, we need to continue cleaning the data. And when you don't know what to clean or what to do, just browse the data. Just open the window and start looking. If something looks weird, then that's when you need to start looking, taking a closer look, and do the changes. In this case, obviously, we notice that the first line has all missings. Basically, it's an aggregated line that we actually don't need. So we need to remove that line. We need to look down. So everything looks fine here. So now we need to delete a line. So let's say, how do you delete row cases or observations? So there is a command called drop. Type help drop. Because drop, you can use it to delete rows. You can use it to delete variables. And you can also use it to delete conditionals to certain under certain characteristics. So in this case, we're going to drop the line. So, and the syntax for this, according to the help page, help drop, is drop in 1. So let's say you want to drop line number 7, you just put drop in 7, so on and so forth. So select the line, and let's click and run it. And if we go back, so there is the line that we don't need is no longer there. So we're cleaning, we're preparing the data, right, as we import. Now the next step is a little bit more advanced, and I thought, I have to think hard about, showing this at this point, especially if you are just beginning to use Stata. I don't want you to be scared. This is just to show you one other command that you probably will use down the road. And this is about loops. Now, loops are to be used when you want to do the same process many, many times. So in this case, one of the challenges that this data is giving us is that we need this date, January 22, 2020, January 2023, 2020, to be on the variable name, because we need the dates. This is a time series data, or cross-section of time series data. Each country is observed over time, so we need those dates. And one way to do this is to rename the variable with manually, but then you will have to do this 952 times probably, one by one. So the other way is to use a loop to, let's say, grab B5 and replace this with the name. Grab B6, replace this with the name, so on and so forth. So that's what the loops are. So in this case, is for each V, we're going to save this into, you can say V, X, num, whatever. This is just a macro. It's something that, like a virtual storage. So basically, for each V of var list, the list of variables that start with a V, this is a wildcard, because everything starts with a V, or everything that we want to change starts with a V. So we can use a wildcard. Otherwise, you will have to type V5, V6, V7, all the way to V957. So to save some time, we're going to use the wildcard. So basically, this is going to get the list of all the V variables. And then it's going to start, you see this curly bracket, the commands in between curly brackets, Stata is going to run that. So it's going to create another virtual storage called C or set. And that is going to extract, this command extracts the variable label of variable V. So in this case, it's going to grab V5, for example, and then it's going to get the date that corresponds to V5. So this one, January 22, 20. And then we're going to do another virtual storage. We're going to substitute sub in the string. So within the string, we are going to substitute in the local C that we say before, we are going to substitute the forward slashes with the underscores. You see, that's forward slashes. Again, Stata doesn't like forward slashes as variable names. So we need to use underscores. Now, comma, all the commands in Stata have options. So after comma, you put all the options that you need. In this case, the option that we need is all. And all means that I want you to change anything, all the forward slashes, because if we don't put all, it's just going to change the first one. So we want to change all of them. And then once you say all that is saved, the next step is to rename the variable. So it's going to say, okay, let me bring B5, and then we are going to put a prefix, because remember, the labels start with a number, right? So we need to put a letter before the number. In this case, I'm just going to put an X. You can put whatever letter you want, but it has to be a letter. And then bring me the macro W. So the macros are assigned, as you probably know now, is with the left single quote, which is around right below the escape keyboard key in your keyboard, and the right single quote, which is next to the enter key. So all the macros, the local macros in Stata, that's how you identify them. So it renames V5, and then it finishes, right? The curly bracket closes the loop, And then it goes back to V6 and do the same thing. And then it goes back to V7 and do the same thing. And do this 952 times, more or less. So once you've set the loop, select the entire thing, and let's just run it, and let's see. So when you see this end of do file, means that it's done. And if you look at your window, variables window, now the variables have the right name. So we can identify which day is. And the labels remain, so we can double check that everything it works. So once we've done some processes, I think it's time to save. One thing is, make sure you save two things. One is you save the do file constantly, because bad things happen sometimes when you're working. And then save the data. So the data, we import the data, but we haven't saved it as a Stata file. So there is a command called save. Here you can put whatever name you want. I try to use a smaller name as possible. So this is the cases, and then the comma replace means that if it already exists, and let's say you do some changes and you want to redo the file, it replaces the existing file. If you don't put that and the file exists, it's going to give you an error. So let's just run this line and then go to the main Stata. So the first time you're going to get this thing that is not error. So it's Stata found not found, because obviously there is nothing to replace. And then it says it's saved. You also can save the file by just saying file save as. Now, any extension DTA is a Stata file, and that's how it is. So once we have this, we already saved it. Let's do some quick descriptive statistics, and you can get that with the command summarize. Summarize basically runs the summary statistics for all the variables in the data. You can also, in this case, let's just help summarize. So you want to see more options. There are a couple of other commands where you can also get summary statistics. One is called tabstat and the other one is called table. You can also type help tabstat or help table to see what those files, those commands do. So let's run summarize for now. And summarize kind of like gives you a quick summary statistics of all the data. So it gives you the number of observations, the mean, the standard deviation, the minimum value, and the maximum values. This allows you to kind of start looking into the files, see the variables, see how they look. If you look at this one, zeros, so obviously there is no way to get summary statistics with string variables, right? So if you see a numeric variable here that should have some values here, but you see zeros, it means that that variable is in the string format. So anything that is numeric, you can estimate the summary statistics. In this case, the last variables are just strings. So that's just a quick summarize. Now, if we have a string variable, let's say, for example, the one at the top, which is province and country region. Let's go back to the browse. So this is the provinces and this is the country regions. Basically, we are interested in this column because it has the names of the countries. Because we cannot get summary statistics as the other type of variables. The summary statistic for string variables are called frequencies. And you can get frequencies in Stata by using the command tab. It's short for tabulate. Type help tab, and then there is one-way tab, which is the frequencies, and two-way tab, which is the cross tabulations. In this case, we're going to do frequencies. So you start with the command line again, tab, and then put the name of the variable that you want to get a frequencies. So I'm going to select this and run, and this gives you the frequency of the. So frequency is basically the number of times each category appears in the data. So in this case, Afghanistan appears one time, Albania one time, Algeria one time, Andorra one time, so on and so forth. That's the number of times. The percent is basically the number of times divided by the total number of cases, basically 1 divided by 285. And then the cumulative file is, the cumulative column is basically, it keeps adding up to the point, let's say, for example, all the way up to Antigua, we have these countries are basically 2.46% altogether of the entire data set. And this goes all the way to 100. Here. So, and this frequency allows us also to see, or to start checking the data. So the frequencies and the script statistics that we get over here is not just to have an idea what the center value is and stuff like that. It also gives us an idea where there are some errors in the data. For example, here is you expect that all these variables start with 0, right? If for some reason you see something like a negative, a huge negative number here, then there's something wrong with that data, probably. You need to look into that. In the case of the frequencies, all of these has string variables, as we see here. These are all in red. We can start seeing some issues here. So there are 8 Australias, there are 16 Canadas, there are 34 Chinas, there are 12 France. So which it's kind of weird. So this data has what this data has is that it also has some provinces, and in some cases, like for example the United Kingdom and France, it also assigns some of the colonies in there. So that's why we have 8 Australias here, for example. Right? So that kind of like tells you or prompts you to do or to make a decision of what to do about it. So in our case, to make life easy for us, in this case, what we're going to do is we are going to aggregate the data. And this actually gives me that opportunity to show you, because sometimes you want to aggregate data. So let's say, for example, you get data for one particular country, and the data is at the probably lowest level, let's say county level, and you don't need county level, but you need to aggregate the data to a state level. So you convert the data from county level to state level, so you need to aggregate that. So, so I'm going to show you how to do that in Stata. So in this case, what we want is we don't want 12 Frances, we want only one, right? We want 34 Chinas, we want only one, 16 Canadas, we only want one. So it's might be controversial at this point, but this is just to show the way to do this. In Stata, there's a command called collapse. So again, help collapse gives you more information on what you can do with this command. And the syntax is command collapse. You need to, before each variable, you need to tell Stata what is it that you want. The default procedure is a mean. In this case, because we're going to collapse, we're going to aggregate number of cases. We want the sum, and you put that in parentheses. There are also procedures for string variables. You can see that in the help page. Sum, and then you need to tell Stata which variables you wanna collapse. And this allows flexibility, because for some variables, in some cases, you don't need the sum, you need the average, right? Then you will type mean and then the variable. So this allows you to treat each variable differently. So it's not like you can apply the same to everything. So you can apply, for some variables you want the mean, you take the mean, and other variables. You can actually get different statistics from the same variable. Let's say you want to take the mean of variable 1, but also you want the median, so you can also type median, B1, so on and so forth. So in this case, we're going to use again the wildcard X, because all the variables that we want to aggregate are the dates, and they start with an X. So every command has an option section, which is separated by a comma, so make sure you put the comma there. You need to do the Stata by, this is a must-have option, basically, because you need to collapse the data, but you need to tell Stata by what, right? So in this case, we're going to collapse it by country region. So select the line and then run. So it takes a little while. Now it's done. if you notice, the name of the file is no longer here because every time Stata runs collapse, is basically it kind of creates a new data set. Right? So let's check the frequencies again. And now we went from 280 something to 199. So that means that we have 199 countries. And then everything is 1. So the data is looking good so far. And now here is where things start getting a little bit interesting because we don't want to override the file that we already have. Sometimes it's good to keep the original files original. So what I'm going to do is I'm going to save this as cases underscore AGG, like a short for aggregate, and then replace. In case I had to go back to this, I don't have to re-import files. I just can open the cases file, which is in the original format, and then redo and do the corrections that I needed. So I'm going to save that file like that, just for now. So my suggestion here is always keep your original files original, in case you have to do something else. Now, if you remember the comment that I make at the introduction, this data is considered a panel data. It's a cross-sectional time series because each country is observed over time, right? But the format is not the right one. So this format is known as wide format, right? We need to transform this data into a long format in which each unit of analysis or each row, each observation represents country and time. So, so instead of having one Afghanistan, we need to have 950 something Afghanistan, 950 something Albania's, 950 something Belgium, so on and so forth. So we're going to make this file really big. So it goes from 199 to thousands of cases. And that means that what we need to do is we need to reshape the file. So Stata has a command for that. It's called reshape. If you want to know more about it, just type help reshape, and there are examples, and there are more specific description of the command. And here we're going to say, okay, you need to reshape long. You can also reshape wide, but in this case we need the long format. So we're going to reshape long. In here, you reshape everything that has the same prefix. If you notice, all these variables, the date variables, the only thing that they have in common is the prefix x. So the only thing you need to put in the reshape before the comma is just whatever prefix is, right, x. This is the same as, let's say, for example, instead of dates, you have years. You put an x before the year, and then you just put x. Now, the I refers to an ID. So look at the comma. We are going into the options section. So the I is basically the ID. The ID basically identify the individual rows, and they have to be unique. So they cannot be duplicated. In this case, we're going to use country region as our ID because we know, based on the frequencies that we got, there is only one of each. So there are no duplications in there. And J is the variable the new variable that we are going to create. Basically, the J is the variable that where we are going to store the dates. Now, since the dates have a /, right? So this is underscore. So January underscore 22 underscore 20. Stata considers this a string name, text name. If we don't have these underscores, it will be just numeric. But because we have the underscores, we need to tell Stata, hey, by the way, the variable names are in string format. So let's go ahead and run that. One other thing is whatever, I forgot to mention that into the collapse. Let me just back up a little bit. In the collapse, all the variables that are not in the collapse are not going to appear in the data. So make sure that you put all the variables that you need. So here in the reshape, let's just run that now. So it's running. Depends on how powerful your machine is. It's going to take a little while. There you go. So now it gives you a little report what Stata did. If you look at the window, the variable windows, instead of having over 950 variables, now we only have 3. And if we go to the browser, yeah, now we have everything in long format. So we have the countries and the time format, and then we have the variable that, in this case, because it's only cases, all the cases in the right format. Now, as we did before, let's rename X. So because X is not a real name, each value refers to cases. So I'm going to run this. Cases, and then we create the cases here. So the variable cases. Now, if you want to, this is optional, if you want to add a label to the variable, there is a command for that, label variable cases. Here you can just put cumulative cases. This is helpful sometimes when if you forgot or you don't work with the data for a little while, then you come back, you can see what the label, the new variables, because you actually made this variable in this format. Now, the next step is, so now that we have the cases there, if you look at the date is in a string format, so text. We need to modify that. So if we are gonna, because date is is part of the time series structure of the data, so we need that variable in a day format, which is also a numeric format. So Stata has a procedure for that, in which we can convert a string variable into a day variable. So what I'm going to do is I'm going to move this here. So, and the procedure uses the command called gen. Gen is short for generate. Type help gen if you want to know more about it. Gen, we're going to generate a new variable. I'm going to call it day var, right? Because day variable. And gen variable, the gen command can actually work with functions, formulas, and all that. In this case, we need a function that is part of the gen command, and that function is called date. The date command, the functions, so start with the name of the function, and then you put the parentheses. Then here you need to put the variable that has the date that you want to change. So in this case, it's also called date. And there is a little comma here separated with options. You need to tell Stata which format the dates are in this data, so in this variable. So if you notice, everything starts with the month, and then the date, and then the year. So you can say month, day, year. And then comma, and then you need to put something that is over 2000. This is for it was part of the Y2K, but also the changes in centuries. For example, if you don't put that 2999, because we only have two digits, Stata may understand that this is October 10, right here, October 10, 1920, instead of 2020. So this is just to make sure that we have the years in correct format. So select that and run. And here is the day bar. So you notice there is a day bar there. Now, this is how Stata counts dates. So dates, Stata starts with January 1st, 1960. So basically January 1st, 1960 is 1. January 2nd, 1960 is 2, so on and so forth. So basically October 10, 2020 is day number 22,198 since 1960. Now that's how Stata understands dates. For you to put it in human format, so there is a second command called format, and you need to tell what are you going to format. So I'm going to format day var, and here I'm going to use the syntax. This is part of Stata. Just start with a percentage sign, and then you put a T as in Tom and a D as in dude. So basically time daily. So you're going to say, okay, if this data is in daily format, so I want to make sure that it's in daily, in the proper format. If we have monthly data, it will be TM. Quarterly will be TQ, so on and so forth. All of this you can see if you type help format. So all those examples and explanation descriptions are in there. So let's just select this one and run. And now you can understand those numbers. So, right? So this is October 19, 1920. I mean, the format in this data is basically day, month, and year. That's fine. If you don't like that, you can change it. I just commented out this one. So just remove the asterisk, and then you can say, I want it in month, day, and year. For the most part, I just leave it as is because that's how most of the code in this data works. So this is up to you. All right, so we finished cleaning the cases data. So now that we have a finished product for the first data file, we can save it with a final name. So I'm going to call it cases final to signal that this is the data set that is already clean. So I'm just going to select and run. Go to the main data, make sure that there is no reds in here or errors. And that was the cases, right? Now we need to do the same thing with the deaths data. Now, how do you do that one? So for that one, the easy way is because both data sets come from the same, exactly the same source, and they have the same format. One thing I did to complete the rest of the code is basically I select pretty much all the way from here, right-click, copy, right, and then paste it down here, and then just make sure to change the name of the dataset. So instead of confirm, I just put that, and instead of cases, I just change it for deaths, right? Anything that says cases, I replace it. So what I'm going to do here, I'm just going to actually run these chunks of code. You see, we're back to where we were. I'm just, and this is what the nice thing about having a do file, so you don't have to stop and just, you know that one part of the do file worked. So there are no errors. The names of the variables are there. I'm going to save it. You can summarize. We know that all of this is going to be pretty much the same because it has the same structure, right? So we're going to collapse, save it, reshape, browse, rename, add the label. So I'm going to just run all that. So instead it's basically running the same thing for the deaths data set because they are the same. They have the same format. Depending on how powerful is your computer, it will take a little while. So here is the death data with the variable created and the label. So the next step is to create the day variable and save it as finals. So that was, once we work on the first one. The second one is pretty much a mirror. It's a mirror image of the first one. So now let's import the WDI data. The WDI data comes from the World Bank. Here is the link in case you want to download the data set. We only get the GDP per capita 2015 constant values and the population and population density for all the countries in the data. Now, the format for this data is Excel, XLSX, the latest Excel version. The command here is import Excel. Make sure you tell Stata where the data is. Sometimes you have different tabs within the same Excel, so you need to make sure to map that there. We see the first row means that you need to make sure that the first row in the Excel file has the variable names, and clear is just to remove whatever file exists in the data. So we can just run this one and see what happens, but let me show you. Sometimes while you get used to Stata, it's easier just to use the menu, and it's okay to use it. So sometimes I actually use it. So import, now we are going for the Excel one. We're going to browse. This is the WDI file. I'm going to open, and this also gives you a little preview of this. But in this case, if you notice, the column names are wrong. It's A, B, C, D, E is the alphabet. So we don't want that. The column names are part of the data here. So that means that we need to check this one, import first row as variable name. Just check that, and then the names go into the at the top. If you have other tabs in Excel, and the first one is, or the default one is not the correct one, you can just select it here. And then just press OK. Since we are using the menu, you get this error. Do you want to continue and replace the data menu? Because there is a file already open, that's the data set. You just type yes. Press yes. Right-click copy from the history window, and let's just paste it here. Since we have the working directory, and to make this a little bit more cleaner, so that's the same code. So next time you want to redo this, or let's say a few weeks later you re-download new data sets, and you want to rerun the code, you don't have to do all. You don't have to use the menu again. You just run this line. Okay. So let's see. Let's do browse. Let's check the data. So in this case, again, we have country names here, country code, and we have the variables right here. Stata. The nice thing about keeping the original names that come from the data set is that Stata, we can use those as labels. When Stata imports them, it removes any empty spaces and put them together to a certain length. So we're just gonna check that the data is correct. Let's go down. And remember what I told at the beginning of the introduction. Here is an issue. This data comes, because we didn't open data in Excel first, it comes with some footnotes in here. Let's assume that we didn't do this, we didn't see it, we don't know what the problem is. But I'm going to keep this to see what happens when you don't clean the data before or check the data before putting it into the software. So let's just keep it there. Let's see what problems it causes. So to make this data a little bit cleaner, because this is the same year, time, and time code basically refers to 2021. So we don't need those two columns. So what I'm going to do is I'm just going to remove them. Remember the command drop? Well, we're going to use that to remove variables. Here in drop, you can just list the variables that you want to drop from the data. So select and run, and they are gone. Now the next step is to rename the variables. You see those names are really long and really hard to remember and to type. So one way to do this quickly is basically if you double click from the variable menu, the name of the variables. So just click that. You see that arrow right there? Just click on the arrow or double click on the name. Every time you do that, it puts the variable into the command line. So once we have that in the command line, I'm just going to copy and paste them and put them in the do file, right? So, and then just type enter every time there is a new variable. So now that gives you the list of variables that you want to change. Now, the next step is to rename, is basically just rename country name. This is the old name. I'll just put the new name. I'm just going to call it country. Short, straightforward, right? Then rename country code. I'm just going to call it C code. So on and so forth. So just keep going doing that. I already have the code right here. So I'm just going to select all the lines and run them. And now we have a cleaner list of variable names. Again, because there is a country variable which is in a string, we can get the description that is for that is a frequency. So, and this reminds me, if Sometimes professor advisors ask you for descriptive statistics of categorical variables or string variables. What they're asking is for frequencies. So, and we can see that pretty much there is only one of everything. So I think we're good. 266 countries. The data set for the World Bank also has some regions. So it has also the world here, South Asia. So it's not all countries. So these 266 countries and regions. All right, so let the fun continues. All right, so what you see here is part of the cleaning process, and this is also part of something that is related to you having a bigger idea of what you're going to be doing. So since we have data sets that come from 3 different sources, when you, at the end of the day, what you want is you want to put all those files into one. So you work with only one data set. So basically that means that you need to merge all those 3 files into one. Now, to merge all those 3 files into one, you need to have at least one variable in common across all 3. So the variable that is common to all 3, in this case, is country. And the country variable for all 3 data sets are in a string format, so basically text. So that means that we need to make sure that in order for all the files to match perfectly, all the names of the countries have to have the same spelling. And when you pull data from different sources, and your data or your analysis at the country level, or your analysis at the state level, or your analysis at the company level, those sources have different naming conventions. So you have to kind of like somehow make them similar. So basically what you do is you have 3 data sets in this case. We're going to select one data set, which is going to be the reference data set, and we're going to make the other 2 similar to the one that we use as a reference, or primary data set. In this case, we're going to take the primary data set is going to be the COVID data. So we're going to change the world values survey data and the WDI data to match the COVID data names. Now, how do you know which match and which don't match? Basically, you have to do, this is something that you have to do probably manually. In this case, this is the WDI. What I usually do when this happens is, you want to minimize the error, select the list and then just copy and just paste it in Excel in one column, and then get the list of the COVID data and paste it in Excel next to each other, and then manually see what the names are. So I did that before in preparation for this session. So, and these are the ones that are different. So this is from the World Development Indicators. And to replace the names, or to make sure the names of WDI match the names of the COVID data, we are going to use the command replace. So the variable country in the WDI data is called country. And here, for example, it's going to say replace country equals to the Bahamas, basically, this is the name that the COVID cases uses. If, this is the conditional, only if country is equals, this is its 2 equals, first equals in the first one because that's a function, that's a formula, and this one is identity. If country is equals to Bahamas, this is how WDI calls the Bahamas, right? Same with Brunei, replace country equals Brunei. This is the correct name in this case for matching purposes. If country equals Brunei Darussalam. So basically this is the name that WDI uses. So basically I went through all the lists, compare from the names from both data sets, and these are the ones that we need to change in order for this data to match the other one. So select, once you finish typing all that, select and run. It's always one replacement. Right? So now that we have that, there is one last check. Now we have a country. We can just keep the country code for now. And we have all these, the 3 variables that we want. Now it's time to save the data. I'm going to just save it as WDI 2021 because that's the year for the data. When naming, you need to kind of like, when you name your files, make sure that you name the files with something that is gives you information about what is in there, right? So try not to use fancy names. Just try to use short and very descriptive names. So when you see the name of the file, you know what is in there. The same for folders and the same for all. So it's easier for you. You don't waste time trying to figure out what is what. So let me just save. And that saves the data. All right, so we have one more data set to go, the word value survey. I'm going to do the same thing. So this one is in Excel format too. This is an all Excel version, but the command is the same. In this case, I'm just going to run that from the do file because you already know how the mechanics work. So I'm just going to run that, and that replaces the value. This is public opinion data from the word value survey, asking people how much confidence do they have in the government for some selected countries. And this happens, there is the 7th wave, 2017. So the surveys were conducted between 2017 and 2022. So we want the recent one to see the levels of confidence. Again, we're going to get some frequencies for the countries to make sure that there is only one. These are all the countries in this data set. And if you want to check it out, just type browse. So basically, each country has basically the percentages. So a great deal in Albania is 2.8%, quite a low 11%. So if you add all of this, it adds to 100. And this is the sample size for each country for that survey. Now we're gonna have to do the same thing with like we did with WDI. After looking at the list of countries and the names, these are the ones that we need to change so that the word value survey matches the COVID cases. So I'm just going to select that and run. It makes the changes. And let's just save the data. I'm going to call it word value survey 7. So that's the 7th wave. And we are done basically importing the data and doing some cleaning and preparation for the analysis. Now the next step is to put everything together.